Okay, in this video lesson, we'll be reviewing exponents, specifically negative and fractional exponents. So in previous courses, you looked at the different properties associated with exponents. The most common one was the product property, where it said, multiplying like bases, you simply add the exponents. The example, b to the m times b to the n, b to the m plus n, simply adding the exponents. Or the quotient property, the next most popular one. When dividing like bases, simply subtract the exponents. Again, b to the m divided by b to the n, b to the m minus n. So it's illustrated in just add the exponents when the base was the same, subtract the exponents when the base was the same. We'll look a little closer at the quotient property. Three different situations. The first, where the b to the fifth divided by b to the second, b to the 5 minus 2, simply subtract with an answer of b cubed. Next situation, where the exponents were the same. b to the fifth divided by b to the fifth, simply subtract the two exponents, giving us b to the 0. The third is where we subtract two exponents, and the final answer is a negative exponent. So we'll look a little closer at b to the 0 and b with the negative exponent. If I brought a problem that actually had real numbers, b squared divided by b squared. If I apply the quotient property and show that I simply subtract the exponents, that'll give me b to 6 to the 0. Now this doesn't help me see what actually 6 to the 0 equals, but because it came from this problem, I'll work it out a little differently. I'll next use PEMDAS, order of operation. So if I was to apply PEMDAS, I would first square each number. 36 divided by 36, and of course that equals 1. So what that illustrates is that 6 to the 0 actually equals 1, which brings us to a new property, the property of 0, which essentially says, in words, it says any number other than 0 raised to the 0 will equal 1. I said it again. Any number except 0 raised to the 0 equals 1. So now let's go a little further with the negative exponents. If I look at this problem here, and if I rewrote it as a fraction as opposed to decimal, still says the same thing, b squared divided by b to the fifth. If I put each of the bases in expanded form, I would get b to the second, which is b times b, and b to the fifth, b times b times b times b times b. And if I begin to simplify by reducing, so each of these b's becomes a 1. B goes into b one time, b goes into this b one time. I can do it a second time, and again end up with the 1s. Now if I simplify, 1 times 1 is 1. 1 times 1 times b times b times b is b to the third power. And so when we compare, here I simply apply the property, subtract the two exponents, and end up with a negative exponent. Here where I took the exact same problem and I took a different procedure and reduced, I ended up with a positive exponent. But when I compare the difference, I begin to see the impact of a negative exponent. The negative exponent simply means to reciprocate your answer. So that gives us the property of negatives. B to the negative n is the same thing as the reciprocal, 1 over b to the positive n. So the way one would approach it is you ignore the negative. Go ahead and simplify the problem, and at the end, reciprocate. So now let's transition to fractional exponents. With fractional exponents, it says that we can simplify or expand it separately. So my exponent right now is a fraction. It's saying that this can be rewritten as the y root, if you will, of a all raised to the x. So what this is basically saying, if my x is the numerator and my y is the denominator, the x as a numerator will be treated as the exponent. And y as the denominator will be treated as the root index. So you can't look at this as an entire fraction. You have to look at it as two separate values. So here's an example. Right now, I could rewrite it. The 3 is the exponent, and the denominator, the 4, is the root index. So it's a two-part problem. So first, we'll look to simplify the fourth root of 16, which is 2, because 2 to the fourth, or 2 times 2 times 2 times 2, is 16. Now that we've simplified the fourth root, we'll look at raising it to the third power. 2 to the third power is 8. So therefore, 16 to the 3/4 is 8. Looking at another situation now. Here we don't just have a fraction, but we also have a negative fractional exponent. So in this situation, it's actually a three-part problem. We'll deal with the root, we'll deal with the raising, and then I'll reciprocate. So if I wrote it in expanded form, there's the cube root of 27, all raised to the -2 power. So we'll first take care of the cube root of 27, which actually equals 3. 3 times 3 is 9, times 3 is 27. Now we'll raise it to the -2, which means we'll do two things. We'll first raise 3 to the second power, which is 9, and then we take the negative, tells us to reciprocate. Final answer, 1/9. So that was a review on just negative exponents and fractional exponents. Hope that helps.